This video is about a brief introduction to the Arduino development environment, recommended for those who are currently getting acquainted with the Arduino world. Arduino IDE Development Environment. Once we have familiarized ourselves with the most essential parameters, we can proceed to use Arduino. The circuit can be connected to the computer via a USB cable, which, in most cases, also provides power, and through this connection, we can program and communicate with it while the program is running. As mentioned at the beginning of the page, Arduino comes with a software development environment, the Arduino IDE and Arduino functions. Arduino functions are accessible in the C++ language, but during development, using basic C language elements is sufficient. These functions greatly facilitate the configuration and use of the microcontroller on the Arduino board. The essential parts of the IDE include the text editor, the compiler, and the serial monitor and serial plotter used to display messages from Arduino. The software environment developers aimed for simplicity, providing a fairly streamlined integrated environment that is easy to learn to use. Upon opening the IDE, you get a template code consisting of two functions. The first is the setup function, where it's recommended to write functions handling settings, and it runs only once at the start of the program. The other is the loop function, where the code written will continuously loop, forming an infinite cycle. For microcontroller running codes, it's crucial not to return from the main program since they don't have an operating system. When the microcontroller receives power, the code on it automatically starts and will run until we disconnect the power. In the Tools Board menu, the currently used Arduino board should be selected, example Arduino UNO. In the Tools Port menu, you should choose the virtual serial port through which the device is accessible. If multiple COM ports are visible in the list, and the Arduino name is luckily found in the list, select it. If not, the simplest way to find out which COM port the Arduino received is to unplug it, observe which port disappears, then reconnect it, and now you can choose the right one. To compile the written code, click the Verify button, checkmark icon, in the upper left corner. Pressing the Verify button is often unnecessary because, by clicking the Upload button, arrow icon, next to it, the compilation starts first, followed by uploading the compiled code to the microcontroller. The compiler and IDE messages can be seen in the black background terminal at the bottom. If an error occurs during compilation or upload, it appears in orange. A common mistake is not selecting the correct COM port before clicking the Upload button. In this case, the environment informs you that it can't connect to the device on that port. A very useful feature of the environment is that it can display messages coming from the microcontroller on the monitor. Clicking on Tools Serial Monitor opens a small pop-up window where you can see incoming messages. In the lower right corner of the window, you need to select the communication speed board, which must match the speed set in the code. In the Tools Serial Plotter menu, you can achieve the graphical representation of numeric messages coming from the microcontroller. Here too, you need to select the appropriate baud rate. This tool is very useful for measuring analog signals, as I demonstrated in a previous short video. In the File Examples menu, you can find numerous example codes categorized appropriately, which can be very helpful in getting to know the environment and even later when starting a specific project.